Welcome to qnawire.
In this question, we are basically looking at a relativistic situation for an electron, and we want to find the velocity with respect to a relativistic situation. So in this case, the momentum, we will have to use the relativistic momentum, gamma times mv, where gamma is actually equals to square root of, 1 over square root of 1 minus v square over c square. What we're going to do is we're going to bring this square root to the left hand side, and we're going to square both sides. This is what we get. Then we're going to bring the term with v square over to the right hand side. To be m square plus p square over c square times v square. And if you were to rearrange this, you can get b square this is the expression, and now we can take the square root of this entire expression. So now to simplify this a bit and to make it into the expression that we need, from the question, we gonna multiply c over c, to the numerator and denominator, and we're also gonna divide the numerator and denominator by p, 1 over p. So what we will get from here is that v is equals to c over, we have m square c square now, and we have to divide by p square plus 1. Now we substitute in p. What is p? The de Broglie's wavelength formula. P is equals to h over lambda. This still holds, as I mentioned earlier in the question, that it still holds for relativistic equations. And so therefore this will be equals to c over square root. Substituting in p equals to h over lambda, we get c lambda over h square plus 1, which is the expression that is stated in the question. Now we need to do a bit of binomial expansion. Gonna simplify this formula a bit. We bring the fraction up, so this is just c multiplied by 1 plus h squared to the power half. Now given that, this is negative half, because it's from the denominator. So given that our lambda is small compared to h over mc, basically you can see this as lambda divided by h over mc. So if lambda is small compared to h over mc, it means that this factor over here is less than 1, much less than 1. And as we know, with something like 1 plus x, where x is much less than 1, power of n, we can use the binomial expansion. Binomial expansion would be equals to 1 plus nx plus so on and so forth. But we're only interested in the first order. Right, this is the first order approximation. We just take up to the second term. So if you do the binomial expansion for this, our x is basically mc lambda over h square. This is our x. And our n is negative half. So by binomial expansion of this expression, we should get c times 1 plus mc lambda over h square times negative half. Right, this is an approximation to the first order, second term. This will be equals to c1 minus half times mc lambda over h square. And so with the term that was expressed in the question, we want our v to be written in terms of c times 1 minus some delta. In this case, our delta will be just equals to half times m square c square lambda square over h square. Right, this is our delta over here. Now to use it in an actual case for an electron, such that is the Broglie's wavelength is 10 to the power minus 15. Right. Want to find what is this particular value of delta, so we can substitute in where we substitute in lambda over here, and as well as the other constants, right, like the mass, in this case the mass of the electron, speed of light, the wavelength, as well as the Planck's constant. We should get delta to be about 8.5 times 10 power minus 8. Therefore, the velocity should be equals to 1 minus 8.5 times 10 power minus 8 times c.